So let's answer these questions on forces and dynamics. Question one reads two masses, M1, 3 kilograms, and M2, 10 kilograms, are on a horizontal frictionless surface and they are connected together with the rope as shown in the figure. So using this diagram, the rope will snap if the tension in it exceeds 50.0 newtons. Question M, what is the acceleration of the whole system when the maximum force is applied? What is the acceleration of the whole system if the maximum force is applied? And question B, what is the maximum value of F which can be applied? What is the maximum value of F which can be applied? So on part A, when they say what is the acceleration of the whole system when this maximum force is applied, they've told us to say when the maximum force is applied, um, the tension in the string is going to be 50 newtons. The tension in the string is going to be 50 newtons if the maximum force is applied. So those are the conditions that we are going to use. We're going to say what will be the acceleration if the tension in the string is equal to 50 newtons. So we're going to use that approach. That is question one. And we should calculate acceleration. Calculate acceleration if tension is equal to 50 newtons. Like that. So if you look at this diagram that we've been given here, can tell to say these are, or we've been given two masses, and since these masses are lying on a surface, we can indicate free body diagram. So there's mg pointing down there, there's a normal force pointing up. Even here, there's a normal force pointing up, and there's also mg pointing down. In the string, there's tension pointing in front there and tension pointing behind there. So the question is, what is the acceleration of the whole system when the maximum force is applied? So we've already explained to say when the maximum force is applied, the tension is equal to 50. So if we look at this or this mass M1, you're going to notice to say summation of forces in the x-axis will be equal to mass multiplied by acceleration, of which specifically we're dealing with M1. What are the forces acting on this particular object? It's only tension, which is pointing in front towards the direction of acceleration. So T will be equal to M1 multiplied by acceleration. What are we looking for? We are looking for acceleration. We know the mass one to say it's 3 kilograms, and we know the tension since we're using the maximum tension, which is 50 newtons. So I'm going to say tension is equal to M1 multiplied by acceleration. We're looking for the acceleration. And this acceleration obviously is going to be the acceleration of the whole system since this system is connected together using an inextensible string. We're going to say acceleration will be equal to T over M1. So this will be equal to the maximum value, which is 50 divided by M1, which will be 3. So that means the acceleration will basically be equal to 16.67 meters per second squared. So this will be the acceleration if the maximum force has been applied. We can go to question B. The second part of the question, which is what is the maximum value of the force which can be applied? What is the maximum value of the force which can be applied? So what are we going to do in order for us to find the maximum value of the force that can be applied? Let's look at the forces that are acting on the second block, which is mass 2. So in the x-axis, we can say summation of forces in the x is equal to mass multiplied by acceleration. And what forces do we have? We have F, which is pulling this object in the direction of motion, and we have T, which is opposing the direction of motion. Let me just try to rub something. We have T, which is pointing backwards. So that means I'm going to have F minus T being equal to M2A. And let's now go to our blackboard. We're going to use that for part B. This was part A. Part B, we're going to say we have F minus T being equal to M2 multiplied by acceleration like that. Okay, so what are we looking for? We're looking for the value of F. So I'm going to say my F minus what is the maximum value of tension? We said it's 50. This being equal to the value of M2, we said this is 10 multiplied by the value of acceleration, which is 16.67. Okay, so F will be equal to, I multiply this by 10, I'm going to get 166.7 plus 50. That means my value of F will basically be equal to, or my maximum value of F will basically be equal to 216, 216.7 newtons. So this is the maximum value of F that can be applied for you to reach the maximum tension which the rope can take, which is 50 newtons. So that, ladies and gentlemen, is all about question one. We can move on to the next question, which is question two. Question two is saying a child is pulling a box of mass 2 kilograms along a smooth horizontal surface using a force of 10 newtons at an angle of 30 degrees to the horizontal. Question one, find the vertical and horizontal components of the 10 Newton force. Question two, work out the acceleration of the box. And question three, calculate the magnitude of the normal reaction between the box and the floor. Okay, so this is also another very, very simple question. Let's just try and visualize the question using a free body diagram. So this is now question two. Question two. Okay, so a child is pulling this box, and this box has a mass of 2 kilograms. I can just write it here. Has a mass of 2 kilograms. And since it is on a horizontal surface, there is a normal reaction force, Fn there. Then they've said the force of 10 newtons, which is applied at an angle, which is of 30 degrees to the horizontal. 30 degrees to the horizontal. This is the data that we've been given, and this is a frictionless surface. Okay, so this is our free body diagram. And since the applied force is applied at an angle, that means we can resolve it into its respective x and y components. So we have an x component there, which is adjacent to the 30 degrees, so it is going to carry a cosine. So this will be 10 cos 30, whilst in the y-axis, I'm going to have 10 sine 30 degrees, like that. Okay, then from here now, we can start solving the questions. Part one is saying calculate the vertical and horizontal components of the 10 Newton force. So this is part one. The vertical component, the vertical will be equal to 10 sine 30. 10 sine 30 degrees, the vertical component. Let me just punch it in. 10 sine 30. 10 sine 30, this is equal to 5. So the vertical component is equal to 5, whilst the horizontal, this is 10 cos 30. 10 cos 30, this is 8.66. 8.66. This is newtons. Even this other one is in newtons. Okay, that is all about question one. Question two is saying we should calculate the acceleration of the box. The acceleration of the box. So in order for us to calculate the acceleration of the box, this is part two, we're going to use Newton's second law of motion. So the summation of forces, the acceleration is in the x-axis. So the summation of forces in the x-axis will be equal to mass multiplied by acceleration. What forces do we have? We have the force which is producing the actual acceleration, which is doing the work, which is this guy, the 10 cos theta. So 10 cos theta, which is 8.66. 8.66 newtons will be equal to mass multiplied by acceleration. What is the mass of this particular box? It's 2 kilograms. So this is 2 multiplied by acceleration divided by 2. Even here divided by 2, that means the acceleration of the box is equal to 8.66 divided by 2. Divided by 2, this is 4.33. 4.33 meters per second squared. The acceleration of the box is 10.33 meters per second squared. Part three of the question is saying we should calculate, or we should work out the magnitude of the normal reaction force between the box and the floor. Okay, so this is part three. And in order for us to calculate the normal reaction force, we're supposed to look at the forces that are acting in the y-axis, since the normal reaction force is in the y-axis. So we are going to consider the forces that are pointing up to be positive and the forces that are pointing down to be negative. So in the positive direction, we have the normal force itself and the vertical component of the applied force, whilst in the negative direction, we have mg. So since the forces that are in the y-axis are at equilibrium, we're going to say summation of forces in the y. This should be equal to 0. So this would be equal to Fn plus 10 sine 30 minus mg. This should be equal to 0. This basically means that Fn plus 10 sine 30, which is 5. I can just say plus 5 plus 5. This should be equal to mg. The mass is 2 multiplied by gravity, which is 9.8. Okay, so let's just punch this into our calculator. 2 multiplied by 9.8, this is 19.6, minus 5, it's 14.6. So the normal reaction force, Fn, is equal to 14.6 newtons. And that is all, ladies and gentlemen, on our question 2. That is all on question 2. We can move on to the next one, which is question 3. And question 3 is saying a body of mass 15 kilograms moves on a horizontal plane with an acceleration of magnitude 2.2 meters per second squared. It is subjected to an applied force of 155 newtons, whose direction is given in the figure. Calculate the coefficient of kinetic friction, rounding the result to the nearest 2 decimal places. Take the acceleration due to gravity, g, to be equal to 9.81 meters per second squared. Okay, so this is the diagram that have been given, and they're asking us to calculate the coefficient of kinetic friction. The coefficient of kinetic friction. So the forces that are acting on this particular object are the applied force itself. Then there is the weight of this particular object pointing vertically downwards. And there is the normal reaction force, Fn, perpendicular to the surface. Then there's the friction force, like that. And what else? The applied force, the 155, is applied at an angle, which means it's supposed to be resolved into its respective x and y components. So we're going to have the x component, which is adjacent to the 45 degrees. So we're going to have 155 cos 45 degrees there. Then in the y-axis, we're going to have 155 sine 45 degrees, like that. Okay, so this is what we have. Now we can bring our formulas from Newton's laws of motion, specifically Newton's second law of motion. So I can tell to say the quantity we are looking for is in the x-axis. So let's do the summation of forces in the x-axis. Let's do the summation of forces in the x-axis. So go to the blank board. This is question 3. Question 3, we're going to say summation of forces in the x will be equal to mass multiplied by acceleration, like that. What forces do we have in the x? We have the force that is directly producing acceleration, which is the x component of the applied force. And we have the frictional force here. So we're going to say 155 cos 45 minus friction. This will be equal to mass. The mass is 15 multiplied by the acceleration. The acceleration is 2.2 meters per second squared, like that. Okay, so I plug 155 cos theta into my calculator. 155 cos 45. This is giving me 109.6. 109.6 minus the formula for friction. We know to say friction is equal to mu k multiplied by Fn. This will be equal to 15 multiplied by 2.2. 15 multiplied by 2.2, this is 33. 33, like that. Okay, so from here, we're going to say mu k, or 109.6 minus 33. 109.6 minus 33 is giving me 76.6, so 76.6 will be equal to mu k multiplied by the normal force Fn. We're looking for mu k, which means we're going to divide both sides by Fn. Fn here, we'll divide it by Fn. So our mu k will be equal to 76.6 divided by the value of our normal force. And if we check the diagram again, the normal force is in the horizontal axis. So let me just rub these so that we can calculate the normal force just from here. You can tell to say the forces that are in the y-axis are at equilibrium since there is no motion in the y-axis. So we're going to say, we're going to consider the forces that are pointing in the positive y direction as positive, whilst the ones that are pointing in the negative direction, y direction as negative, which means these two are positive, whilst this one is negative. So I'll say our normal force, Fn, plus 155 sine 45, 155 sine 45, sine 45, this is 109.6 or so, plus 109.6. This should be equal to mg, which is 15 multiplied by 9.81. This is 147.15. 147.15. Okay, like that. So that means our normal force is 147.15 minus 109 minus 109.6. 37.55 is the normal force. Our Fn, normal force, is equal to 37.55, like that. And that is the value we're going to get to plug into this formula. 37.55. So our mu K, something must be wrong here. Something must be very, very, very wrong because the coefficient of friction must not exceed 1. Let me just counter check what is happening. Okay, so I've tried to counter check and I've just realized that I haven't made any mistake at any particular step. This is what it's giving me according to the data that they've given us. So mu K is equal to 2.04. This is two decimal places, as they have said. The coefficient of kinetic friction is giving me to be 2.04, just like that. So this is large, very, very large. And the coefficients of friction must not exceed 1. So that just shows that maybe there was an error in the numbers that were given in the question itself. But according to what we've been given, that is what we are getting. You can go to the next question, which is question 4. Question 4 is talking about an 8.0 Newton block accelerating down a frictionless incline at 15 degrees to the horizontal. What is the magnitude of the net force causing the block's acceleration? An 8 Newton block is accelerating down a frictionless incline at 15 degrees to the horizontal. What is the magnitude of the net force causing the block's acceleration? So they've given us this diagram to explain the motion that they are talking about. So this is a very simple question because they haven't mentioned to say there is any external force that is being applied here. This block is accelerating purely due to the influence of the horizontal component of the weight of this particular object. So we can calculate the magnitude of the net force that is calculating this block's acceleration because they've given us the weight of this particular object and the angle of the incline itself. So we're going to say question 4. This is now question 4. Question 4, we have an incline there at 15, and this guy is accelerating going downwards. Then the incline is at 15 degrees. And as usual, we've been given the weight, and this weight is going to be resolved. We have weight cos theta here, which is cos 15. And here we have weight sine 15. Sine 15 degrees. So this is a frictionless surface. That means the magnitude of the force that is or the magnitude of the net force that is causing this acceleration will be in the x-axis. So summation of forces in the x, or F net in the x, will be equal to um, the force that is causing this acceleration, which will be W sine 15 degrees. That is the only force that is causing motion in the y-axis. So that is the net force that is causing reaction. So I'll say my F net will be equal to 8 sine 15. Sine 15 degrees, which is giving me a value of 2.07 newtons. 2.07 newtons is the net force that is acting on the block and causing this guy to be accelerating down the incline. Just like that, we are done with question 4.